Hello guys, and welcome back to the channel. So we'll be looking into trees here. So trees are what hierarchical data structure with a root node and what child node. Now we have different types. We have the binary tree, whereby each node has at most two children, and we have the binary search tree (BST), whereby we have the left child to the parent and to the right child. So we have the tree transversal algorithm, whereby we're saying in order, pre-order, and what post-order. So in the in order now, I was saying left, root, and what right. Then in pre-order, I was saying root, left, then what right. Then the post-order, we're having what left, right, what root. Now application where we in application for this stuff, we use it in an hierarchical data representation. So now organizing data like file system or organizational structure, we also is also efficient in for searching and what and sorting, especially in BSTs. Now let's actually like see how this guy is actually what works. Now let's go to our VS Code to actually try this. Now we could just come here to create what, let's say trees, that's what HTML. Now I'm saying this, yeah, I'm doing, let's say script, right? Script. Now in my script now the first thing I need to do now, I need to what create a class, a class of what. The first thing I do is what I define a node class. So I say class class node, right? So in my class node now, I also what I have a constructor of this. Now inside I say what value, right? Now the next thing I do now is this. I say this dot value is equal to what value, yeah, right? Now what am I trying to achieve here? I'm saying what this stores what the value of what of the node inside what inside this guy. Now the next thing I'm having now, I'm saying this dot left, right? This dot left is equal to what null. Now this guy is just what a pointer to the what to the left child, in the initially what set to what to null. Now the same way I just say what this dot right equal to what null, exactly the same thing. Now after doing this, now the next thing I need to do is to actually define my binary tree class. Now I can now say this class binary tree, right? Binary tree, Abby. So we're having it this way. So now I have a constructor. Now in my constructor now I'll now say this. I can now say this dot root is equal to what null. What am I doing here? I'm just trying to what initialize the root of the tree as null. Now the next thing we do now is to actually what create a method. Now the first method we'll be creating now is to what insert a new value into the tree. Now how do we do that? Now we now say is, let's say insert, insert, call it insert, then I'm saying value. Now I'm not saying this. Now here now we just say const new node, right, equal to what new node, right, and what with the value, yeah. So what are we trying to gain here? We're saying what we're trying to create a new node with a given value. Now the next thing for us to say now is this. We say if this, right, if this dot root is equal to what null. Now we're saying this. Now I'm saying this dot root is equal to what new node, this way. Now upon doing this, now what I'm trying to achieve here. Now I'm trying to achieve a situation where I'm saying I'm creating what. So I'm saying this, if the root is actually empty, now I'm actually going to set the new node as the root for it. Now I say my else statement. Now I say else what should happen. Now I'm saying else this dot insert node. Now inside it now I'm saying node this dot root, comma, I'm now saying new node, this way. Now what am I trying to achieve here? Now I'm trying to say otherwise where you should use what an helper method. So I'm asking to what use an helper method to actually what find the correct place for the new node. Now the next thing for us to do now is what to create that helper method, whereby it helps us to like actually what put the new node into its correct place. Now I could now call this one. I could say insert what node. Then now inside it now you say what node command. Then I'll say what new node, right? This way. Now inside is the first thing I'll be having an if statement. I'll say if what new node dot value is actually what less than what node dot value. Now what I need to do now, I'm saying this, I actually need to what so I actually need to do this. I want to say if inside that same if statement, if node dot left, right, dot left is equal to what null. Now what should happen? Now I'm saying this should happen. Node dot left is equal to what new node. Now what am I saying? Now I'm saying what if there is no left child, I want you to what set this new node as the left child. Now the next thing I have is what my else statement. So I say else what? Now say else this dot what insert, right? Insert node. Then I say this node dot left, right? So in the note I say new node. So now I'm actually saying this. Otherwise I want you to actually continue to the left subtree. Now the next thing is the else statement for the main if statement. So I can now say else. Now in this else now I'm saying if node dot right is equal to what none, right? I'm now saying this. I actually want something, so I will say node dot right is equal to what new node, this way. So now after this, now the next thing I actually say now is what else, right? Else what else I can now say this dot insert node. Then I will now say node dot right command. Then I say what new node, this way. So we can now say this. Now the next thing for us to do now is actually what to create another method. Now this method now is actually what to the method is to perform what the in order traversal of the tree. Now I could say this in order. Now I can now say node is equal to this dot root, this way, this dot root. Now say this if what node, right, is not equal to null. Now we're saying this dot what in order. Then I'm saying this dot in order. Now I'm saying node dot what dot left. Then I say console dot log of what node dot value, right? Now and I have what this dot in order, right? And we'll say node dot right. So what am I trying to say here is this first one now it transfers what the left subtree. Now this one just visited the current node, and now why this one transfers to the right subtree. Now let's see. So the next part for us to do is to create the method to perform the pre-order transfers. Now say this, I can say pre-order this way. Now say pre-order, I could say node dot node is equal to this dot root, right? This dot root. Now I can now say this. Now I'll say if what node is if node is not equal to what null. Now I want you to what do this console dot log of what node dot what value. That's the first thing. So the first one is built as what the root. Now the next thing I say now is what I will say this this dot what pre-order. Now I'll say node dot what dot left here this way. So I can now say the last one this dot what pre-order. Then I'm having what node dot what dot right here this way. So this is how our pre-order method is going to look like. So we're saying what this one now is actually what visit the current node, and now this one is what transverse what the left subtree, and this one is what to transverse what the right what subtree. Now the next one we're looking, so the next method we'll be having is what this is the post order. Now we say post order here. So in the post order now I can now say this. Now let's say node, right? Node is equal to what this dot what dot root, right? So now the next thing we have is what if node is not equal to what null. Now we're now saying this the same thing. The first one that comes here now is what is this dot what post order. Then I'll now say this node dot what dot left. So in the post order now we transverse what to the left first. Now we now say this dot post order, right? Post order. Now and I say what node dot what dot right. Now after the left we transverse what to the right. Then the last one is what is the node, is the root. So say console dot log what node dot what dot value. Now the last thing we'll be looking into now is the method to create the search. Now this method actually helps us like search for a certain value in the tree. So I will say search. So search what? Now we say node then value, right? Then inside here now I can now say this if node is what equal to what null. Now the first thing I'm saying now is what is this. So if the node is equal to null, I want you to what return what null, right? Now we now have another if statement. I say this if value is less than what node dot value. Now I want you to actually do this. What I want you to do is what return this dot search, right? This dot search. Then I say what node dot left comma what the value. So what am I trying to say here? I'm saying go to what the left subtree if the value is what is actually what less. Now I say my else if statement. Now else if what value is what is actually greater than node dot what dot value. Now I can now say this. So here now say what return what this dot what dot search. Then say what node dot what dot right comma the what value. Now we now have what an else statement that says this else just what return the what node. That's all for else. Now we've actually written all our method. Now it's time for us to actually like try out how every one of them is actually working. Now let's see. If we say coming out of this our binary tree scoop, then I could say let tree, right? Let tree equal to this new what? I could say new binary tree, right? So we're saying this. Now the first thing I'll be saying now, I'll say what is tree dot what 3 dot insert, 3 dot insert. Now say insert what? 10. Yeah, the first one. Now when I say 3 dot what? 3 dot insert of, let's say, 5. Now you know this first one I'm saying 3 dot insert of 10. What do you think happens? It's actually what? Insert 10 as what? As the root node. Now when I say this 3 dot what? Insert of 5, it's actually what? Insert 5 as in the what? The left subtree. Now if I now say this 3 dot insert, right? 3 dot insert, let's say 15. Now what does this one do now? It's actually what? Insert it, insert 15 what? In the right what? Subtree. Now if I now say this 3 dot what? Dot insert, let's say of 3 also. Now what does this guy now do? It inserts 3 in the what? In the left subtree of what? Of 5. Now if I now say 3 dot what? Insert of, let's say, 25. Now what does this one do now? It actually what? Insert 25 in the what? Right subtree of what? Of 5. Now let's continue now by what? Testing out every method we actually what? Used. Now we say the first one we testing out, and let's say console.log. So I could say this in order, right? Now let's see how this in order is going to actually take out. So I could say 3 dot what? Dot in order. Abi 3 dot in order. Then I say this. Now let's run our code to actually see how this guy runs out. So we say open live server. So we have our output here. So let's say Control-Shift-I to see our console. Now, as you can see now, we're seeing what? The in order. Saying what? 3, 5, 10, 15, and what? And 25. Now let's understand something. Now in our slide, you know, we said this. We said when we say the tree traversal algorithm, now we say the first thing for the in order is what? Left, root, then what? Then the right. Then for the pre-order now we have what? Root, left, then what? Then the right. And the post-order is what? Left, right, and what? And the root. Now let's see. Let's go back to it. Let's see. So let's use the pre-order and the rest. So I could say console.log. So we're actually doing what we're working with. So I could say pre-order, right? The pre-order transverse. Now say this 3 dot what? Pre-order, right? Now if I say this now and I put this, automatically now if I come to the output now, we'll be having something like this. Now in the pre-order now you can see we're having what? 10, 5, 3, 15, and what? And 25. Now if we come back now and say the one for the post order now, console dot log as what? Post order, right? So now we can now say this 3 dot what? Post order this way. Now let's see how it comes out for this. Now this guy actually what? Comes out this way. Let's refresh. Now for the post order, I can see we're having what? 3, 5, 25, what? 15, and what? And 10. Now let's come back and actually what? Try our last method we created, the what? The search. Now let's say I'm saying console.log. Abi? Now I can say search for value, let's say 25. Abi? Let's say value 25. Now at this point now I can now say this. So I'll say const what? Result, right? Result equal to what? 3 dot what? Dot search, right? Now in this 3 dot search, I'll now say what? 3 dot what? Dot root, right? Now give the value I'm looking for, which is what? 25, right? So now if I now say this, I'll be using let's say console.log. Now I could say this result what? If result is actually, if it's actually what? Found, then I'm saying what? I'm saying this, say what? Found, say what? Found. Then I'm saying result dot what? Dot value this way. So now close this guy back now, or I'm saying what? Not found, this way. Now if we're to run our code now, let's come back now. Now I'm seeing this, search for what? Value of what? 25. I'm saying what? Found what? 25. Now if I'm saying this, let's come back to this, and I'm saying let's say 35, one of them we don't have, and I come back and I say what? Now what are we having now? And when I refresh, we're saying what? Not found. This is it about what? About trees. So the next part now we'll be moving into heaps. Thank you. So let's talk about heaps. So now heaps are what? A special tree-based structure that satisfies what? The heap property. Now we have different types. We have what? The min heap, whereby it has what? Whereby it is what? The parent node are what? Less than or equal to what? Their children. Then the max heap now, the parent nodes are what? Greater than or equal to what? Their children. Now the key operations we have there are what? Insert, when we want to add what? A new element to to actually what? Maintain what? The heap property. Now we have the delete to actually what? Remove the root and what? Reorganize what? The heap. Now let's go to VS Code to actually see how this guy actually works. Now the first thing for us to do now, we could say heap dot what? Dot, let's say HTML, this way. Now I can now say this, let's say this, right? Now inside I can now have my what? My scripts. Now inside my script now say this. The first thing I'll be doing is what? Creating a class of what? Of min heap. Now inside it now, and I'll say this. I create my what? My constructor. Then a constructor inside I say something like this. This dot heap is got what? An empty what? Array. Now the next thing I do now is this. Actually what? Insert a new element into what? The heap. And by doing that I say what? Insert, right? Insert, create a method called what? Insert what? Element. Insert element. Then I say this. Now I say this dot heap dot what? Dot push element. This actually what? Adds the element to what? To the end of the what? To the end of the array. Now if I now say this dot what? Bubble dot bubble, let's say bubble up, right? This dot bubble up. Then I say this. Now what does this guy actually do? It actually what? Moves the element to what? To its correct position what? In the array. Now I can now, the next thing I have to say is this. I actually was create a new method called what? The bubble up method, right? Now inside this now, and I'll say this. I say let's say let index equal to what? This dot heap dot what? Dot length my what? Minus 1. Now the next thing I'll say is this. I create a loop where I say while what? While index is what? Is actually what? Less than 0. So and I'll say let parent index equal to what? Math dot what? Dot floor index what? Minus 1 abi, then divided by what? By 2. Now the next thing I'll say is this. If what? If this dot what? Dot heap, right? If this dot heap, then I say this parent index. Now then I say this is what? Less than or equal to what? This dot what? Dot heap, right? Dot heap what? Index of what? Index. Yeah. Now I will now say sorry. Then I say what? Break, right? Break. So and I'll say this way. Then the next thing I say now is this, right? This dot heap, right? Now this dot heap, then inside I say what? Parent index, right? Then and I'll say comma, sorry, so comma, then I say this dot what? Dot heap, then I say what? Index, right? So the next thing I say under what? Comma, then here I'm saying, so yeah, I'll be saying equal to what? Equal to this dot what? Dot heap, then what? Index, right? So index, then comma, and I'll say this dot heap, then parent index, just right this way. So now say what? Semicolon here. Now the next thing now I say is what? Index dot what? Parent index. Now this just to what? To update the index. Then this update what? Update index what? The parent what? Index here for us. So guys, the next thing for us to do now is to create a method whereby it can actually what? Remove and return what? The smallest element root of the what? Of the heap. Now how do we do this? We say this. I say let's create a new method saying this. So let's call it extract min. Abi? Let's use capital letter here. So extract min. So I will say this now. Now inside the first thing I say is if what? If this dot what? If this dot heap dot length is equal to what? 0. I'm saying what? Return null. You get me? I'm saying that if the heap is empty, return what? Null. So at this point I do this. Now the next thing I do, I write another if statement whereby I say this. If what? If this dot heap dot length is equal to what? 1, then what? Return this dot what? This dot heap dot what? Dot pop. Right? Now what does this guy do? It actually does this. If the heap is actually what? It actually has 1. What does it do? It actually what? Removes it and add it back. Now we say this. But now next I'll say const min is equal to this dot what? Dot heap. Right? This dot heap, then index of what? 0. Right? So now what I'm just doing here now, I'm storing what? The smallest element inside what? This. Now I say this. The next thing I say this dot heap index 0 is equal to what? This dot heap dot what? Dot pop. Now what's this guy saying? I'm asking to what? Move the what? The last element of the what? I'm asking to what? Move the last element to the what? To the root. Now the next thing I say is this dot what? Dot bubble down. What does this guy actually do? I'm actually asking him to move what? The root element to what? To its correct position. Now we're going to create a method called what? Bubble down now. So we say bubble down. Then inside the bubble down we'll say this. So we'll say let index equal to what? 0. Then I say const length is equal to this dot heap dot length. Right? So I'll now say this while true. Right? While true. Why this is true? I want this. Let left child index equal to what? 2 times what? Index plus what? Plus 1. Now what does the next thing I say now is this. I say let right child index equal to the same thing. But this time 1 plus 2. So and if what? If left child index is actually what? Less than length and this dot heap, right, of left child index, right, is actually also less than this dot heap, right, smallest, this way. Then I say smallest is equal to what? Left child index. The smallest one referring to is this guy. Let smallest equal to what? Index. Now let's go to the answer. Next what I say is if what? If right child index, right, is actually what? Less than length, right, then we say and this dot heap, right, right child index, right, then I say is actually what? Less than this dot heap of what now? Smallest, right? So we now say this. Now what I say here is now I say smallest is equal to what? Right child what? Indexed. Now the next part we say now, we say if what now? If smallest, then we say, so if smallest is equal to index. Now what should happen? Now I'm saying this, break. Now what are we saying here now? We're just saying this, if no swap is needed, then it should actually what? Stop. Now the next thing we do now is this, we say, sorry, let's please. So we say this dot heap, right, index, right, comma, then I say this dot heap of, let's say, smallest, right. So then I say this is what? Equal to this dot heap of what? Smallest, comma, this dot heap index, right. So the next thing I say now I say index is equal to smallest. Now what am I trying to achieve here? I'm updating the index to the what? To the smallest index. Now the next thing for us to do now is to create another method. This method now is actually what? Is actually a method that to actually return the smallest element without what? Removing it. Now we can call this this method pick. So let's see how it works. So we say pick, right? Pick. Then I will say this, if what? This dot heap dot what? Dot length is equal to 0. Now I'll say what? Return null. You should return all null if the what? The heap is actually what? Empty. Now the next thing we say now is this, we say return what? This dot heap index of what? 0. Now this guy actually what? Returns the smallest element root, the smallest what? Element that is in the root. Now let's see how every one of this our method works now. So coming out of this our scope, now I can now say this. The first thing, let's instantiate our class. So I will say const what? Let's say min heap. Const, sorry, no, that's capital. Min heap, right, is equal to new what? New min heap, right? So let's start. So I can now say min heap dot insert, right? Now let's insert something. I will say insert 3 min heap dot insert let's say 4. So let me just copy this guy. I don't write it one by one. So another one, let's say 7, another 9, another 10, another, let's say 1, right? So let's say another as what? 0. Okay, so now the next thing for us to do now is this. Now we want to actually see what? The smallest number. Now the first thing we'll do this, we say console dot what? Dot log, right? Console dot log min heap dot what? Dot pick, right? Remember, that's what the method is all about. Now let's run this code to see our output. So let's say Control Shift and I. So as you can see, the smallest number we have is what? Is 0, right? This way, the smallest number we have is what? Is 0. Now if I now say this, console dot log min heap dot extract min. Now remember what this guy do. This guy actually what removes and what return what the smallest element. Now is to do this, it will what remove 0, then actually return it for us, right? Now let's see how it's going to look like. Let's refresh. Sorry. As we refresh now, showing the smallest number as what? As 0. Now we say this now. Sorry. Now if I say console.log of min if also dot peak once again. Now the smallest number will actually change. Why? Because we have actually what removed it by using what this extract min method. Now if you come back here now and say this, as you can see, we're having what the smallest number as what as 1. Why? Because the extract min has actually what removed this guy but displays for us, right? That's what this guy, that extract min actually did. But now the peak now is letting us know that the smallest number in that heap now is what is 1. This doesn't make sense. So this is how this guy actually what. So that's all about heap. Now the next thing we'll be looking into now is after the heaps we'll look into graphs. So what's a graph? Said a graph is a data structure that consists of vertices or nodes that represent what entities or what or points. Why? And also it also consists of what edges. This represents what connections between what pairs of what vertices. So we have different types of graph. We have the directed graph, we have the undirected graph, we have the directed graph whereby the edges have a direction, and we have the undirected graph, edges have what no direction. Now the next thing now, the representation of what of graphs, we have the adjacency matrix, we have the adjacency list. We also have the transversal algorithm for graphs, whereby we say the BFS, whereby we talk about breadth first search. We also have the DFS, depth first search. Now applications where we use graph mostly in network routing, finding the shortest path in networks. We also use this in social network analysis for like find friend recommendations and connection on all these social media apps. We also use it on maps. Also we use graphs on maps also. So now let's jump into VS Code and see how we can work around graph. So let's start by creating a file for the graph. So graph.html. Now in it we have this script, right? So now what's the first thing to do now? The first thing for me to do now is to create a class called graph, right? Now inside it I have a constructor. Now I say this dot adjacency list is equal to an empty object. Now what am I trying to achieve here? I'm initializing an empty object to actually store an adjacency list. Now the next thing for us to do now is actually to create a method. What does this method do? It's actually add a vertex to the graph. Now we say this. I can say add vertex, right? Add vertex, then I will say inside vertex, then if not this dot adjacency list, right, of vertex this way. Now and I'll say this dot adjacency list, then array vertex. Now is equal to an empty array here. Now what am I doing? I add the vertex with an empty array at this point here. So now and I'll say this. Now the next thing for us to do now is create another method. Now this method we want to create a method whereby it can add an edge between two vertices. Now we now say this. I will say add edge, right? Add edge of let's say vertex 1, then we say vertex 2, right? Now we could have this. Now I can now say if this dot adjacency list, right? Then vertex 1 and this dot adjacency list of what? Vertex 2, right? Then I say this, let me make it this way. Then I say this now. I say this dot adjacency list of what? Vertex 1 dot push, right? Of what? Vertex 2. Now this guy, what does he do actually? It actually what? Adds vertex 2 to what? To the vertex. Now, and I will say this, the next thing I say is this dot adjacency list, then I say vertex 2 dot push, right? Of what? Vertex 1, this way, right? So now after doing this, now the next thing for us to do now is to create the next method. Now this method, the next method we're trying to create now, the remove edge method. Now what does it do? It's actually what? Remove edges between what? Vertex. Now when I say this, remove edge, right? Remove edge, then I'll say vertex 1, vertex 2. Now I can now say this. Now I will say if what? If this dot adjacency list of what? Vertex 1, right? Then and this dot adjacency list of what? Vertex 2, right? So now we now say this. We say this dot adjacency list of what? Now we say vertex 1 is equal to what? This dot adjacency list, adjacency list of what? Of vertex 1, right? Then dot filter. I can now say this v, then lambda expression v is not v, then I say is not equal to vertex 2, right? Now the next thing for us to do now, we say this so vertex, then we say this vertex this way. So I say while what? While this dot adjacency list of what? Vertex, right? Dot length. Now I want you to what? Do this. Now I say const adjacent vertex is equal to this dot adjacency list, right? Of what? Vertex right? So dot pop. Now I say this, delete what? This dot adjacency list of what? Vertex, this way. Now the next method for us to do now is to actually what? Print a graph out. So now say this, let's call it print graph, right? Print graph. Then I could say so you could say for what? For let vertex, right, in this dot adjacency list, right? Then I say this, so say console dot log vertex plus, right? Now say plus this dot adjacency list of what? Vertex, right, dot join. Okay, now say this okay, let's try every one of our methods out. Now the first thing we do now is to instantiate our class. So I will say let graph, right? No, let's use small g. Let graph equal to what? New what? New graph, this way. So now we can now say graph dot add vertex, abi, that's one of the method. I will say add vertex of what? A. Now let's say we're having add vertex of A, B, C and D. So we'll have this C, D. So B, C and what? And D. Now the next thing for us to do is to add our edges, right? We've added our vertices. Now the next thing is for us to what? Add our edge. So we say graph, graph dot what? Add edge, right? Now we say A B, right? So I could say graph dot what? Add edge. Then I could have this also A what? A C. So we could have under, we could say graph dot add edge, right? So we could say this B B, let's say D here. Okay, so they are all making sense this way. So let's say sorry, sorry. So let's move on. So I could say console dot log, right? Now inside I could just say graph after adding what? Adding vertices, right? Now and what? Edges. That's what we want to first show, right? So we can now say this graph dot what? Print graph, this way. So let's run this code and actually see the output. Now let's, so Control Shift and I, right? Okay, loading. Now as you can see, this is our graph after adding what? Vertices and what? Edges. So A, B, C, the rest. Now, if we now do this, let's say we were to do the order. What are you saying? Let's say console dot log graph after removing edge between A and B. Now let's say before this console.log we say this. We say graph dot what? Remove edge. Remove edge for what? Now say what? A and what? B. Right? Now we come back and see our output now. Okay, we haven't actually run the function there. So now say this console dot log of what? Graph dot print graph this way. Right, now let's come back to see the output now. So when we refresh, we have this. Now this is our graph afterwards, removing the edges between what? A and what? And B. Now as you can see, the edge, this from here now, A has been removed, yeah, right? B is just what? Remove. Why? Because we removed the what? Edges between what? A and what? And B. So automatically now we're removing this. Automatically this B is being removed and only C is remaining. Automatically here also A is what? Being removed and this what? Only what? Remaining. Now let's see the remove vertex method. Let's check it out. So now I can now say this. We say we say this here, graph dot what? Remove vertex, right? Then I will say this, remove vertex of what? Of C. Abi? Now if I now say this, now if I say console dot log, right, I can now say graph after removing vertex what? C. Abi? Now we can now say this, graph dot what? Print graph, right? Now we could now have what? This guy this way. Let's refresh again. Now as you can see now, it has already removed what? The vertex of what? Of C. Now if you see now the vertex here we're having what? C what? A. But now to actually what? Remove the what? The vertex of what? Of C in this what? In this graph. So this is everything about what? Graph. This is what we stop on graphs. Now the next video you actually be watching is I'll be creating a to-do list app whereby we'll check out some of this data structure, whereby we'll be able to use like things like Heap, star, queues and the rest. So we'll implement these guys in this to-do list app we're trying to like do. Thank you.